This is lesson 106, more on systems of three equations in algebra 2. So let's go ahead and put three equations up here. Alright, so this is example 106.1. Now let's notice a couple things here. In this first equation we have an x and a y. In the second one we have an x and a z. And in the third one we have a y and a z. Okay, so we don't have x's in all three of them, we don't have y's in all three of them, and we don't have z's in all three of them. Okay, so there's a lot of uncommon things. So let's go ahead and pull this over and let me show you the same equation and show you what's missing. So I'm missing the z's here, I'm missing y's here, and I'm missing x's there. Okay, so it makes it not really more difficult, but just a little bit more tricky when we're solving these. So what we're going to do is we are, again, like when we've dealt with any kind of three equation system, we're trying to get rid of two of the variables so that we only have one, and then we take that one variable and plug it back in and see if we can solve for the one variable and then solve for the second and then solve for the third. Okay, so we're given three equations there, and we have a couple choices here. If we are trying to get rid of a variable, we can get rid of the z, we could get rid of the y's, or we could get rid of the x's. So let's say we wanted to get rid of the x's, we would take these two equations and get rid of the x's. If we wanted to get rid of the y's, we could take the first equation and the second equation and get rid of those y's here. Now the book, when they did theirs, what did they do? They're choosing to eliminate x. Okay, it doesn't matter at all. But if you're following along with the book, let's just do it the way they do it. So they're going to use this equation and this equation so that they can get rid of the x's. Alright, so let's just write this as 2x and pretend that a z doesn't even exist right now, or a y doesn't exist. We'll just leave those there. Alright, so let's just get rid of my x's. So I'm going to multiply this x by -2 so that it can go away there. So let's just draw this down below. Let's draw the top one first. And let's distribute. That would be a 6, right? Okay, so now when I add, these go away. I have a 3y plus a 4z. Do not add those together. I mean, it makes it real easy to try adding those, but you don't, because you can't add them because they're different variables, and that's going to equal 2. Okay, so there's one of my equations, and it has a y and it has a z. Now, are there any other ones up here that have y's and z's? Yep, this one right here has a y and a z. So we're going to take this one and bring them together. So let's just do this in blue. And the one we just found. Okay, so now what we're going to do is we are going to do the system of equations with those two blue equations there. And in this one, let's get rid of the z. So we're going to multiply this one by 4. Alright, so let's look at this and distribute. And then we have our 3y plus 4, z equals 2. Now when we add those go away. And my y then equals -2. Alright, so let's look at this just real quick about what we did. Our original equation, and then I stretched it out and I just put spaces there where I was missing a z or a y or an x. then I just choose. All right, which letter do I want to get rid of? It doesn't matter. But we chose to get rid of the x's, so we picked two equations that both had x's. See, I couldn't have picked this equation and this equation because this didn't have an x here. So I have to decide which equation I'm going to get rid of, or which variable I'm going to get rid of, and pick two equations that have that variable. So in this case, I have an x. If I wanted to get rid of the z, I would have picked this equation and this equation because they both have z's. All right. So I picked these two. Multiplied the bottom by -2 so it would cancel with the top one. Okay, and so what I did is I just rewrote the top equation and the middle equation multiplied by -2. Here's the top equation again. Here's the bottom, or this equation right here, when I had multiplied by -2. Then I added them, and my x's disappeared, and I was left with a y and a z. Okay, so I still have two variables. So then I look back up here at my original three equations, and since I have a y and a z here, I find another equation with a y and a z, and I put those two equations together. So this right here is what I put right there, and this here I put here. So I'm bringing those two equations together. So I'm bringing this equation and this equation, and then I multiplied by 4 in order to get this z to be a 4 so that it cancels, -4z plus +4z, so those go away, and then they do go away, and I found out what my y is. Once I find my y, then it's a simple process to find the one with the y with only with a y. It doesn't matter which one of these I pick, but I'm going to pick this one, and I put my -2 in for my y, minus z equals -6. So -4 minus z equals -6. Add 4, and I find out that my z then, -z, equals -2. And if I want to change my sign, I can, and I get z equals 2. So I have z equals 2 and y equals -2. And then it's real quick and easy to just pick, again, any of these equations. I'm looking for x. So I'm just going to take either this equation or this equation, plug my values here in, and find out what x is. So in this case, if I took my 2 and put it in here, I would get x minus 4, 2 times 2 equals -3. X minus 4 equals -3. Add 4 to both sides, I get x equals 1. And I'm done. And then so I've found x, y, and z. Okay, so let's do one more. Okay, so here's example 106.2, and what I did is I spread them out so that I'm missing an x in this one, a y in this one, and a z here. So I kind of it helps me just to kind of figure out which ones I'm going to do. So again, it does not matter which ones you eliminate first. I am going to eliminate these because this has a 1 there, and it's just a lot easier to do that. But it does not matter at all which ones you eliminate. So I'm going to write that in blue over here. 2x minus 3z equals -5, and again I left the space there because I don't have a y there. And the next one I'm going to put as x minus 2y, and I don't have a z here, equals 6. Alright, this needs to be a -2, so I'm going to multiply this whole thing by -2. So now I've got, again on the top, 2x, don't have a y, minus 3z equals -5. I'm going to distribute this 2. Nothing there for z equals -12. Okay, and now I'm going to add. Those go away, and I have a 4y minus 3z, because I can't add these to anything, equals -17. Okay, so I'm going to hold on to that. I'm down to 2 variables there. So the next step is to look at this. Whoops, get my little pointer right. Is I'm going to look at this original set of equations here. I have 3 of them here. And I'm going to take one of these equations that only has a y and a z, and I'm going to add it to this one so I can eliminate another variable. So I've already eliminated one variable. I've eliminated the x. Now I'm going to try to eliminate another one. So this one here has a y and a z. This one has an x and a z and an x and a y. I don't have any x's here, so I don't want those. So I'm going to take this one here because it has a y and a z. Alright, let's put these in dark blue. And let's go over here to the left side. So I've got a 3y minus 2z equals negative 12. Okay, because that one has my y and my z. Then I'm going to take this one and I'm going to put it over here. Okay, so now I'm going to combine these two. So I'm either going to get rid of my y's or get rid of my z's. Doesn't really matter which one. Let's get rid of the z's. The numbers are smaller in front of there. So the number that's common to both the 2 and the 3 is a 6. So I need to make this a 6 and this a 6. And I need to make this one a positive 6 and this one a negative 6 so that they cancel. Alright, so let's see. I'm going to take and multiply this one. What did they say? It has to be a positive 6. So that's got to be a negative 3 so that when I multiply that I get a positive 6. And this one here, I'm just going to multiply it by 2 because when I multiply I'm going to get a negative 6. So that's going to give me what I want. Alright, so let's take this whole thing and rewrite it right below. Negative 9y plus 6z equals positive 36, negative 3 times negative 12. Here I'm going to get an 8y minus 6z equals negative 34. Add those together. I get a negative y, those cancel, equal positive 2. And because I don't want this to be written as negative y, I change it to a positive and change this side to a negative. So there is my y value that I just found. Okay, now you'll notice the book did it differently than I did. It doesn't matter which one you eliminate first. So y equals negative 2. So now, again, I look up here and I find an equation with just a y and something else. So like this equation here doesn't have a y, so I'm not going to look at that one. So let's just take this one, x minus 2y. And I'm going to put this negative 2 in its place. So x plus 4 equals 6, or x equals 2. Alright, so I just found 2 of my numbers. I found y is negative 2 and x is 2. So let's go ahead, see if we can, I don't think I can erase anything at this point. I think everything is locked. Alright, so now what I'm going to do is I'm going to look at one of these equations, because what am I looking for? I've got an x and a y. I'm looking for a z. So let's take this top one and let's put, let's see, the top one, y, so I'm looking for z. So I'm going to put negative 2 in here for y. So let's move all this down. So I have 3y minus 2z equals negative 12. And I'm going to put a negative 2 in there. Okay. And I have negative 6 minus 2z equals negative 12. Negative 2z equals negative 6. Divide by negative 2, divide by negative 2, and I get a z equals 3. And there's my x, y, and z. And that's it for lesson 106.